Hello and welcome to this Conscia webinar, where we're going to talk about how to stay ahead of cyber threats with DEATH, or detection engineering and threat hunting.
My name is Avesta. I'm a security analyst at Conscia Cyber Defense, and as part of that, I perform our monthly hunts. Before that, I used to be a security consultant, and I've currently been with Conscia for around 2 years now.
And my name is Andrew Michael. I'm a senior security engineer also at Conscia Cyber Defense. Started at the same time as Avesta. I work with engineering of our cloud and our SIM and our SOAR platforms. And prior to that, I've worked as a security consultant and also as an educator for cybersecurity. Just briefly, I want to talk to you about the Conscia Cyber Defense in Denmark that Avesta and I work at. We have three main services: our managed detection and response, Conscia Detection and Response, which is a 24/7 detection and response service to allow for public and municipalities and private customers in Denmark. We handle about 1.5 billion events each day and have to somehow automate and reduce these to some signals that we can actually use that give value and we can help our customers out. We also work with some vulnerability management, helping our customers prioritize the vulnerabilities that they find in their infrastructure. And we also work with log management, a managed log management service where we host a SIM platform, log management platform, and give them value into where they can go in and use the logs and use the data that's coming into them. And in all of these services, we really actually use a lot of this detection engineering and threat hunting that we hope that we're going to be able to tell you about today. So what are we going to get through? We're going to be looking briefly at threat hunting, definition of this, what are the benefits of doing it, and then we're going to go on a technical deep dive into a couple of threat hunting scenarios where we hope that we're able to kind of show you how to operationalize threat hunting. So take these theories, these concepts, and how to actually go from a hypothesis down to developing this threat hunt and then turning it in maybe to a detection rule that you're going to be using in your environment. Finally, we're going to take a kind of pull back, do a helicopter perspective, talking about how you may need to get started with threat hunting, what kind of processes, what kind of resources you're going to need to be able to actually develop a threat hunting program in your organization. So if we start off, setting the stage here, what is threat hunting? We'll take a look at what Robert M. Lee from the SANS Institute has called it. It's this: threat hunting is a proactive, data-driven methodology that applies an iterative search for specific events within enterprise data, going beyond standard detection capabilities, a process that is then repeated in recurring cycles over time. So we're proactive. We're not just waiting for something to happen, but we're actively going out and looking for something in the data that we have. We have an iterative search. So we're not looking one time, but we're going to be repeating this. We're going to be developing some processes and programs that we want to repeat on it. And this is focused on some specific events that we have in our environment. It's not just open the logs, try to find evil, not with at least the typical threat hunting approach to it. And finally, this is something that we're going to do again and again and again in these recurring cycles. So this is something that is systematized inside of our organization. And with threat hunting, the outputs from these threat hunting processes, they may either feed into our incident response if we find something that we need to action on right away, or it may actually be fed down into some detection engineering where we just design some new detection rules and new detection processes that we want in our platform. Now, just briefly, a threat is anything in your environment that could cause harm, right? So a potential circumstance or an event that could impact the security of your environment using maybe the CIA principles. But we could also be talking about looking for maybe compliance events or looking for situations like, do we have some vulnerabilities we didn't know about? Do we have encryption turned on where it's supposed to be? These different types of focuses can be interesting for our hunts. And I'll go more into that after our deep dive. Finally, I want to talk about here, why would you want to even consider it? What's the reason that you're maybe tuned into this? And why is threat hunting important when you maybe have an EDR solution or an XDR solution? And the first thing is, of course, threat hunting is this constantly evolving threat landscape, right? We're seeing new actors, we're seeing new attacks, we're seeing new objectives, and we need to stay ahead of this. EDR is going to be doing some of that, but there may be some specific attacks that are going to be focused on our own context. We have this dynamic and hybrid IT environment, so maybe we don't have the visibility, maybe we don't have the coverage, we don't have the security implemented everywhere, so we need to actually go out and try to find it. And then we also have to relate to NIS2, we have to relate to DORA, we have to relate to GDPR, where DORA specifically is talking about proactive use of your logs and your security platform, so that you have to actually go out and actively search for these new events and potential threats in your system. Now at this point I'm going to turn it over to Avesta.
Thank you.
He's going to be starting our deep dive.
Yes. So it all begins with a story. As an analyst, I used to perform research on adversary activity, their TTPs, and how they perform various objectives in our customer environments. And one of the things that I would come across, as shown in the picture here, is the execution of a malware in which the malware runs. It does not create any child processes or any extraneous events, and then the computer is fully compromised afterwards. And while I did not sit down and, whereas normally I would have some background information on a topic and explicitly write a hypothesis for it, you could say that this hypothesis came to me in a natural way, where I decided to learn about malware development and try to figure out how is it possible for me to hunt for various malwares in our customer environments. And so the hypothesis that was born with that was whether or not a malware is executed in our customer environments, and if so, how is it possible for us to detect it? After performing a sizable amount of research on these, I understood that there is something called the Windows API call. The Windows API call is created by Microsoft for programs to operate with the operating systems, in which they can use the Windows API call to talk with the operating system. For example, if a program wants to create a file, what they can do is that they can call the create file event and use that to create a file. If they want to create a registry event, they have to call the create registry key to create a registry key in the Windows operating system. And shortly you will see a malware that we're going to use in this demo, and in that malware it uses the capture snapshot API call that can be used to take the state of a remote process. Now, how could that be useful? Well, if you have a process, for example the LSAS process, in which it contains sensitive information like credentials and hashes, that can be used to capture the state of the process inside the memory, and then later on be used to export that sensitive information from that snapshot dump. So how does it look like when you have a private malware running on a Windows machine that may have Enterprise Defender enabled on it? So the demo that you're about to see is a Windows machine in our lab environment in which we perform adversary simulation on. And in this, you're going to see a private malware that is going to evade the detection and prevention of malware and drop the LSAS process. And then afterwards, we're going to verify that the disk that was dropped is the actual LSAS process, and it contains our sensitive credentials. So going into this, I'm going to play it and just zoom on this just to make it a bit simpler. Here I'm using command prompt to just directly run the malware. To give some context, because this malware is extracting the LSAS process, it is going to run with administrative privileges, as in this case we believe that the adversary has gained access to a machine, and now they're trying to export the sensitive information from the system and use that for their next objective. As you can see on the left-hand side, we dropped the LSAS process was dropped, and now we're taking it back to our, in this case, attacker machine, and we want to verify that the malware did what it is supposed to. So in this case, we drop the file. We have a basic Python script that just fixes the signature for the file for the very famous and public tool called Mimikatz to be able to work against it and extract those sensitive credentials for us. So here we are first running Mimikatz. Then we're going to grab the code in which it directs the Mimikatz tool against the dump file by the private malware. And then we're going to run the code that allows us to extract the passwords from the system. And as you can see here, we have highlighted, there is the hash for the user on that system. So quite an interesting view to be able to see a private malware completely evade and go unprevented on an enterprise security solution. So when you have these malwares running against your security solutions, they are going to create various number of events. And how you will analyze them will depend on your technical prowess and the technologies that you have access to. Simple queries could be looking for certain events or certain values, whereas complex queries can be based on data science where you use advanced algorithms and machine learning. At Conscia, what we like to do is that we like to remain in the middle of the complexity spectrum and use the queries that are given to us by these security solutions and use them to perform various statistical and time-based and anomaly-based analysis against our events. Some various properties that can be used against those data and that you should use to detect these events would be how unique the events are, the context in which the events are being generated, the sequence in which they're being generated, the number of events that are being generated by the malware, whether it's high or too low. And when you're creating these queries, both for your detection rules and for your hunts, there are two key concepts that you need to be aware of. And that is, the first one is sensitivity, and that is how accurate your detection is in detecting every single true positive possibility. The second one is specificity, in which you try to avoid as many false positives as possible. Personally, I like to focus my efforts when creating our queries to specificity rather than sensitivity. When I ran a large number of different types of malware in our environments and analyzed those events, I came to an interesting conclusion and a common denominator between all the malwares that were executed. And that was that if I use the Windows API call data set and look for rare or anomalous processes that are making rare or common API calls, I can detect a large number of different types of malware in our customer environments. And the visual here is shown to give a better view of how the events may look like. Now, the query that you're about to see has already been tuned into becoming a detection rule. This is not certainly always going to be the case because some hunts are going to generate a large number of false positives, and because of that they may not be able to become real-time detection rules since it will cause alert fatigue for your analysts. Now, the way I wanted to detect anomalous and rare processes in our customer environments was using the baselining method. But the issue is that with a static baseline, it is very difficult to maintain and keep it up to date. And so I came across this way of using the dataset itself to create this sort of dynamic baseline. And the visual below will hopefully make it much simpler to understand how the query works. So on a Defender solution or any other security solution, I may have access to 30 days of data. And what we're going to do is that we're going to use the 29 days before today as part of our baseline. And then we're going to grab all the events that are occurring today as our evaluated or sort of attack data and look for processes that are occurring today that has not been seen in our environment in the past 29 days before us. So imagine you have a process that just spawned on a machine and it has not been seen in the past 29 days. that is a rare process in your environment. So how does that query look like on the Defender KQL language? So I'm going to grab the laser pointer and begin from the top. So we're going to use the baseline variable, you can call it whatever you like, and then grab events from 30 days ago up to a day ago. And then we're going to filter on the API call events. Now here, this is a decision that I've made as an analyst. I realized that while these more common API calls are not considered as completely trusted, the level of false positives that they generate is not acceptable for me. So they have been excluded from the type of API calls that we want to detect. Afterwards, we create a set of the hashes and put that inside, which all of that goes into the baseline variable. Then we're going to look at the data set again and look at the events that are occurring from a day ago up to now. And we're going to again focus our filter onto the API call data set, and then look for processes that were not seen in the past 29 days before that. Afterwards, we have some management level code where we try to enrich the hash with the certificate information. This can, and then further on, be used to exclude certain signatures that might make a lot of noise in your environment. Afterwards, we just deduplicate events that may generate too many duplicates. And here we also have the field in which you can use to exclude any noise. Furthermore, you can also use different fields to exclude just specific processes as well. And it is also important to understand that when you are deciding that you're trusting a signature, it means that if any process, malicious or benign, is using that specific signature, it will then go undetected by this query. And so now let's jump into the test Defender environment that we have and look at how this query performs as a detection rule against the private malwares that we have executed in the Defender environment. So I'm going to now jump into the Defender. So here is our test the Defender machine, in which we use the machines inside onboarded into this Defender for our adversary simulation techniques. And to verify, you can see that there hasn't been any Defender alerts created in response to those private malwares being executed in the environment. And on the right-hand side, you can see that the detection source, that this is a custom detection. I'm going to just click on this one. Give it a second to load, go to the events, scroll to the bottom, and here we can see the process that was executed. So this is another form of an LSAS dropper. And for example, you will get an alert for this where you see, okay, this anomalous process opened a handle to the LSAS process on your machine. And when you look to the right-hand side, you can see that, okay, this process has not been sent to a solution like VirusTotal. And when you go down, you can see that, for example, this is an unsigned process. You can see that it has only been seen in your environment, only on the one machine. And then on worldwide, since this is a private malware that might have been targeted to our environment, it has only been seen on this singular machine. So that can be something that rings the bells, and you could then perform further analysis on this process, which in this case is a private malware that drops the LSAS process. So we're going to now go back to the slides.
And just to kind of look at that, we typically get a question from people saying, yeah, but is that catching all malware? Or what's going to happen if we have a developer environment that is generating a lot of new programs that are being that are being run all the time? Is it going to ping out in those cases and raise an alert? And I think that's one of the big things to learn about both threat hunting and detection engineering, is that first off, you're not trying to discover every activity. You're not looking for the perfect one rule that is going to find all malware activity or all malicious activity in your network. So this is something that maybe can get a lot of alerts, or at least generate us on the alerts that are not really known, and it's going to notify us on malware execution that really doesn't have a known hash or some other things there, and maybe it's going to do it with enough true positives and so few false positives as possible, so we don't get annoyed or we don't get bothered by too much noise in the system there, right? So. And then you can scope it out and say, well, it works in this situation. So you have a very scoped out use case for this, right?
That is correct.
You're not thinking it's doing more than it's actually doing.
No.
You know where it is, and you know what its expectations, its limitations are doing. So I think that's one of the first things to learn. There'll be a lot of, oh, but this. Yeah, true. But just know what is actually doing this detection for you.
That is correct. As they say, perfect is the enemy of good.
Yeah.
And there's always that perfect fallacy where you can say, oh, what if this scenario and what if that scenario? And in those cases, your response should be, oh, we have another hunt, another detection rule, another defense against that problem. And you can create this sort of defense in depth in your environment.
Yeah. Okay. So so let's we're going to move on, and I think you're going to be talking about another scenario, and I think where before we had kind of a statistical approach to it, right? Looking at these, is it a new device? Is it a new process? Is it something new on our environment? And that's really actually, all of those are good things to be looking at with regards to detections. This is going to be looking more at behavior-based. So
Yes.
how can we look at a certain type of behavior or flow into our detection?
Yeah, and I'm sure that a lot of people are familiar with this. So ClickFix, the phishing campaign, this was something that began in the early 2024 and had a massive surge worldwide at the end of 2024. And then we saw that at the beginning of 2025, it was starting to be used by state-sponsored adversaries, which is quite interesting. And based on that...
I think maybe we should go more into the detail on what ClickFix actually does, right?
Yeah, that's correct. The way the ClickFix phishing campaign works is that because nowadays the verification steps, the CAPTCHAs, the solutions on the internet have become so complex, the number of images that you have to take, and so on and so forth, the adversaries have used these fake CAPTCHAs and sort of fake fixes for your systems, or for example a fake MFA, in which what they do is that they give you the instructions to copy the certain code from their webpage and then run that on your machine. And what that does is that the code runs, connects outbound, grabs the second stage, which in most cases is going to be a malware, in which the malware then runs on your machine and it compromises your system.
We can see in these examples, right, we have one that's saying push the Windows button, open up this PowerShell command, and then run this. The other one is saying use the Windows R command, and it's preloaded at that point the code that it wants you to run, and use Control V in the system here. So when we first heard about ClickFix, it's like, well, nobody's going to do that, right?
Yeah.
We were very naive at that point because a lot of people are going to do this. And I think actually it makes sense, maybe not on an MFA thing, but it makes sense with regards to, oh, fix your video by doing this, fix your web page by doing this. Oh, we have a new way of doing MFA. How many ways of doing MFA do you actually have in your environment? So a user is going to follow this, and they may not know actually what's going on with the system here, right?
So based on this threat intelligence information that you've gathered now, you can create a hypothesis to say, okay, has this ClickFix phishing campaign that is going worldwide has been successful to gain access to our environment? And let's take a look at an example, infection kill chain. on how ClickFix might operate. So in this example, we have an email coming to a user in which it will have a link to send the user to a web page. When the user clicks on the link, goes to the web page, then they get the fake CAPTCHA or MFA or any other sort of fake page for them to first copy a piece of code and then run that code onto their machine. Afterwards, when that code runs, it is going to then contact a completely different server, domain, or IP, download the malware, and then the malware will execute on the machine. At that point, the malware can perform any action it likes, whether it's persistence, C2, or any other TTP that the adversaries are using nowadays.
And so one thing I think that's important or interesting to look at here is that we have I need the laser pointer. Yeah.
Oh, this one.
Yeah. So just notice that we have no connection here between like the phishing page and then opening up another system or opening up another page or downloading a file or something like that, right? So one of the things with ClickFix is that it breaks that link there. And if we look at the next line here, where what kind of signals could we maybe use to actually build these detections, build these threat hunt rules that we have? So you might first talk about, well, what about DNS queries for that we're going to be seeing either from the user clicking the link, or we may also see a DNS query with the second part or downloading this file here, right? So the first DNS query or the URL that it's going to land on for the ClickFix page, if we analyze that with the sandbox or analyze that with just trying to figure out, does it generate a download? Does it have JavaScript? Does it have some other things, right? This is a static page. It's not going to necessarily appear malicious.
No.
The malicious activity is something that the user is actually performing separately. So things like DNS are also retrospective. We may not be able to block that. We may not be able to block the URL. So what we want to do is, and then the activities that happen afterwards, those are maybe also something we could look at, but what we're mainly interested in is this type of behavior that we're seeing with the user.
Yeah,
And
where the
so-
user is copy and pasting a certain piece of code and then running it on their machine.
And so you're going to be dependent kind of on where you want your threat hunt to go. You'll be kind of gaming that out, but then also gaming it out based on what signals do you have? Do you have actual DNS information? Do you have URL information? Do you have information from the host? These are different types of visualization requests that you might have. Yeah.
Yes.
Or requirements, excuse me.
I will get rid of the laser pointer now. So, when looking at the ClickFix phishing campaigns, one thing I realized between all the large number of examples I saw was that this attack is a staged attack in which the first stage is the code that the page gives you to copy and paste and run, and then that code reaches out outbound and downloads the stage 2. And what is unique in all of these scenarios is that the user must copy a certain piece of code and then run it onto their machine. And so I realized that this sequence tends to be a very unique sequence in our customer environments. And the query that I created to be able to detect this type of activity was that we began by looking at the clipboard events by our users. Now, here you can see that the parent process is Explorer, and depending on the technology that you're using and the security solution and how they log their events, this can vary. Some security solutions will have 2 clipboard events in which they grab the data and they set the data, and the way they are performing the logging could be that the initiating process will be the browser. So you'll see a get clipboard event happening from chrome.exe and firefox.exe. However, in the case of Defender, we saw that all the instances, the copy and pasting from the browser gave us a explorer.exe parent process. So what we're doing is that we are grabbing all the get clipboard events that are occurring with the parent process of Explorer in the past 30 days, and then putting that timestamp of the clipboard events inside a variable. We called it clip time. Then we are looking at process events or the execution of that piece of code in the environment. And the way we're doing here is that we are joining that with the process events, and we're looking to see that the device name must be the same and the account name must be the same, because all of this is happening in one user session. The user is opening the browser, going to a website, copying it, and then running it. So it shouldn't be a different user running a different process. Then this generally will happen in the next 30 seconds or up to a minute. Generally, users are not going to be, hopefully, slower than that.
Yes.
And then the adversaries have commonly executed these 4 processes as part of their code to reach outbound and grab stage 2. However, there is one small problem with that. There are many number of processes on a Windows machine, which we call them living off the land binaries, that have the possibility to go outbound to execute a process remotely outbound, or to download a process and then bring it back to the machine and then running it locally. So to make this list of processes being executed 30 seconds or a minute after a clipboard event, you can look at any living off the land binary that has the capability to run a process, a remote process, or to download it and then running it. However, in the many scenarios that we've saw, adversaries have very commonly used these 4 processes to perform that objective. We again look at the parent process being Explorer, and then we are deduplicating any events that are creating too many duplicate events.
Yeah. And again, this is where the tuning comes in, right? And knowing that you're not going to get the perfect one. But in your environment, what's going to be the noise? What's going to be too many events? What's going to be covering the most likely events? Those types of decisions that you're going to want to make here.
Yes, there are many cases where somebody may actually just copy an event and then have a similar process like PowerShell command prompt being executed. You could have administrators that have these types of activity. However, this will also be able to detect those cases where we had with ClickFix. So I'm going to disable the laser pointer again, and we're now going to go back into the Defender environment and look to see how this query performs when you have a ClickFix attempt happening in your environment. So I'm going to jump out again, going to the browser. In this case, this is a hunt. This is not a detection rule anymore because of the number of noises that it creates. So we're going to go into the advanced hunting, and this can be something that you run on a scheduled basis, whether daily, or in this case, it needs to be monthly because this is looking at 30 days. However, you can always adjust that to your liking. So I can see that the script is already put into the query area. I'm just going to zoom into this, and we can see here is that on the left-hand side, so what we've done is that I copy and pasted a certain piece of code from the browser and then ran that. And in this case, I used a benign script to showcase that. However, in a scenario where it's being attacked, what you would see would be, for example, PowerShell going up to an IP or a domain and running a suspicious process. And to also better showcase that, I'm going to go to the device timeline, since that page won't show the clip event, whereas with this case, you can see that. We just need to wait 1 second for it to load. Perfect. So as you can see here, we have the clipboard event, where in this case, it would be the user going to a website. Previous to that, you could have, for example, here I was using Firefox at the bottom, as you can see here, but it could be a different browser, any browser. It could be a DNS event, them going to a specific domain. Then you would get a clipboard event where the user just copied some piece of data, and then afterwards, you would see a process similar to this whether it be command prompt or MSI exec or any process on a Windows machine that has the capability to run something remotely. So quite interesting.
Mm-hmm.
Yeah.
Yeah. Right, so let's go over and look at like a threat hunting lifecycle and try to relate it to the click fix that we just saw, right? So first you're going to generate this hypothesis that you have, like what are we actually going to be hunting for? And in this case, we might be having a hypothesis that says attackers are using click fix for initial access. So this was, for us, threat intelligence informed. We knew that this was going on, these attacks. We were thinking of, okay, that's going to be what we're looking for. We're going to be hunting for click fix activities and see if this has actually happened inside of our user's environment. And then we get to preparing for the hunt. And preparing for the hunt takes a bit of time, right? So what artifacts or what signals do we have that are going to help us out to look at this, right? So do we have process calls? Do we have visibility down on what's going on at the endpoint? Do we have network visibility? Do we have visibility on DNS lookups? Do we have visibility on through the firewall on connectivity or from the host itself on these network connectivity?
In this scenario, can you see the clipboard event?
Yeah.
If you can't, this hunt would not be feasible.
Yeah. So if we don't actually have the logging or something like that that's going to present that to us, we don't know, we can't do it. We have an infection chain, what's that going to look like? And maybe we've researched it or maybe we've run it in the sandbox and used our own tools to do some forensics on top of it. And then where is the data? Where can we get this? Do we even have it? If we don't have it, do we need to enable it? Those types of things. Sometimes there's going to be a hunt that you want to do, but we're going to have to put it off because you don't have any sort of visualization into the system. Then you also have to ask yourself, what skills do we need to do this? What tools do we need? And I'll go a little bit more inside of that. But again, this needs to have somebody that understands looking at these process lines, looking at this type of behavior, and can decide whether or not this is good or bad. After you've started the hunt or started running the preliminary part of the hunt, you may have some tuning on this. So we got to get rid of these false positives. Are we doing that by manually going through the list and looking for false positives? Can we take some of that information we get and then use it to tune the hunt itself? Realizing that we may also get some false negatives. We may get some results that we missed something or other, but decide if that's okay, right? Yeah. And then finally, results. We get the results back. What do we do with them? Do we just put them in a drawer? Do we say, oh, this is nice, this looks good? Or do we know that we're going to action on them? Do we create a ticket to say, fix this? Do we share it broadly with the team that actually is responsible for securing these devices or doing something about it? And then finally, there will always be maintenance on these threat hunts. These threat hunts might be something you do every month. They might be something that turns into a detection rule that has a period of time when it works, but then starts being less accurate or just being less relevant. Maybe the threat isn't there anymore. So we have this different type of maintenance that we have to look at. So we have this entire cycle between threat hunts in our system.
Yeah.
So now we're going to pivot away from the more technical part and talk more about how would we actually do this, or how would you do this inside of your environment, right? So what would your hunting program look like? And I would almost bet that most of you out there do have some form of hunting program. You have some administrators, some engineers that are looking into log files or looking into events on systems right now. And what differentiates that maybe from the threat hunting that we would call threat hunting and what they're doing now is that it's actually named, that it's a process that you have, and that you're actually systematically approaching this threat hunting process in your system. So I'm going to go through each of these, but we have this kind of basic precepts. You want to allocate your resources. You want to decide what your goals are. You need to make sure that you have visibility requirements for it, and you have to act on the results that we're going here. So allocating your resources. This is very important that you give people the time, because hunting takes time. It takes time to develop the hunts, and it takes time to actually go and perform the hunt that you're going on, because hunts are going to be generating a lot of noise. And when you first do the hunt, it's going to be generating an awful lot of noise until you're able to tune it down. So make sure that if you decide to do a hunting program, that you're going to say, these people have the time, they have the performance. Maybe this person is depending on how your threat hunt is scheduled, you may have a hunt where you have a dedicated resource for 2 weeks. If it's a very large, very well-described hunt throughout your entire system. It may also be something that you say you get 4 hours each week or something like that to focus and spend time on your hunt. But the most important thing is that people are given time to focus and not be disturbed by a lot of other calls coming in or tickets or cases that they have to work on. Make sure that your people have the skills, right? Avesta is very skilled in Defender, and that's necessary for him to be able to go in and perform both the queries, knowledge of the query language, but then also knowledge of what a Windows process looks like or a typical process flow, right? And there's going to be a lot of these skills already in your organization, but you're going to want to leverage them. You're also maybe going to be looking cross-team on this because domain knowledge, the idea that we want to know if something's going on with this specific application, this web server here, you may want to have some cross-team types of threat hunting where that person can contribute with what they know about the application. Because maybe it's a different log, it's got some weird messages out of it, those types of things, and we need to kind of split around it. So have a process then, you've got your people ready, have a process so you know that people know how much time they're going to be spending on this, how you're going to evaluate the output of a process, what you're looking for from the system itself, right? So, and how do we communicate this? So this is going to be a hunt. Is the hunt going to generate a report? Is the hunt going to generate a detection rule? Are we going to evaluate this hunt based on how many detection rules it generates or how many true positives it generates or what systems it actually has as far as coverage? Because there's going to be a desire to use a lot of time on hunts, and it's a big rabbit hole that you can get stuck on, right? Certainly. So just know that you can say stop on some of this. Another typical thing is if you're doing a hunt, if we're doing a hunt for ClickFix, right? And all of a sudden we find something else going on. So we've looked at processes that are going out and connecting to an environment, right? Okay, we find one, and this is malicious, but it's not ClickFix, right?
Yeah, something else.
Then we want to raise a ticket, hand that off to somebody else, because otherwise the hunt can start to go everywhere on it, right? Yeah. Finally, if we go down to technology, make sure that you have the tools that you need, make sure you have the log sources that you need. Defender is really good at looking at these Windows events, these Microsoft events that we have coming on. And it's good at stitching those together. It has a query language, so we can query it and we can correlate across multiple sources. We use a SIM also. Besides Defender, we also have a SIM, which allows us to correlate Microsoft Windows events, endpoint events with firewall events, DNS network events, those types of different events. So the tooling actually helps as well. Do you need tooling? You can do this just with log files. So if you have access to those log files, just like any sort of forensic activity, you can do it. But if you have a place to read those log files in and perform the activity, such as a SIM or such as some other sort of log management tool, then that makes it much easier to actually dig down in the system and find these activities that you're looking for.
Yeah, that's also what I want to add about the tooling is that while it is not required to have any DR solution or something like that, it does make it a lot easier. But what is really required is that you need access to a lot of logs and having the capability to be able to correlate these logs and joining them together to be able to create that story. Yeah,
and so we're really happy with our log management SIM tool that we're using, and the ability to say, okay, I can pivot from this log to that log to that log. The data is normalized, the timestamps are normalized, so I can see what actual activity is actually happening. So I don't need to look in this log source, make some notes, copy some stuff, and then go over and look in this note. It makes it a lot quicker and a lot more valuable, I would say.
Yeah.
Okay. So we've got our tools, we've got our skills, then we need to actually see what it is that makes sense to us. And this is where you need to have an idea on what is important in your environment, in your context that you want to be looking for. Our focus as a SOC, as a managed detection and response, is typically looking at the attackers, like looking at who is attacking us, what's the threat intelligence that's coming in, and what can we do to prevent these, right? And so we might be looking at something like the first one here. Adversaries are using valid certificates for their malware. That may be a hypothesis that we have, and we want to be able to say, can we detect this? Can we hunt for this in an environment? It could also be that you are running some web applications. So you don't know, but you say, I'm worried that one of our critical web applications is being targeted for exploitation. In this case, you're going to need a domain expert on that application, a domain expert on how maybe that programming could be exploited or how somebody might be able to exploit that to get into that. And this may be something that you don't have typical detection rules for, right? There's a lot of lack of detection rules for a lot of applications out there.
Certainly, especially with the rise of cloud applications as well.
Yeah. And then zero-day vulnerability, exploited by our VPN service. Maybe you just heard about that. Maybe you're worried that's something that you haven't seen before. So we have to go and look at our VPN service. What would we be detecting on? What kind of connections? What kind of behavior would be there? In the same way with data being exfiltrated, classified data being sent in clear text, which would be both a security violation but also a compliance violation. Or we may be having an insider is accessing sensitive data. So our threat hunts they're evolving around things that are important to us and important to you in your context. And this hypothesis and this goals, it kind of comes from three main areas, right? It comes from threat intelligence, which is where a lot of our hypotheses come from, right? We're looking at what the attacker is trying to do. So we get knowledge about the attacker's techniques, we get information about their infrastructure, and we use that to generate these types of hunts based on what they might do in our environment. But just as important, but more of an outside in, is either a situational awareness where you know what your environment looks like, you know where your crown jewels are, you know which ways you might be attacked. That would be a way that you could generate your hunt or define the goals for your hunt. Was it possible for somebody to use certificates to compromise my system? Or is it possible for somebody to go in and access data they shouldn't have access to? I think we can do that with a hunt that way.
Or another example would be if you are a broadcasting company and you have machines that are made to broadcast the television, and those are then considered your crown jewels. And so you can create hunts based on those specific systems being compromised by the adversaries.
And then finally, domain expertise. That's, again, knowledge of a specific type of domain. Maybe you really know a lot about DNS, maybe you know a lot about a specific server or something like that, and using that to focus the hunt and saying, let's just go ahead and think what could happen here. That's a very open-ended hunt where you're looking for anomalies. You may not have an idea, you may not have a behavior pattern, you may not have something there, but you're really digging through logs looking for a lot of different anomalies.
And just to add, these hypotheses are not necessarily need to be coming from just one of these three areas. A really good hypothesis can be created from using two or more of these different types of ways to develop your hypotheses.
The most important with a hypothesis is that it's testable, right? That you can actually do something on it and you can evaluate whether or not you've reached a goal there or not. It's falsifiable. Yeah. So now we've got our goals, we've got our skills, and now we need to make sure we have visibility, right? So you've defined your goal, now you need to make sure you have these visibility requirements. And you could have data sources from all sorts of places, right? Critical assets, applications, cloud, network data. How do we get these sources? How do we interact with them? What tools do we have at our disposal, right? We must make sure also that we have an actionable and usable format, right? So it's not just necessarily a log, but the log needs to tell us something. It needs to be something that we can maybe parse, that we can get some value out of it. And what we have here at the final point, start with both standard and important areas that can provide you the most value, right? So standard is, okay, of course we got our firewall logs. Of course we have our identity logs. Of course we have some logs from some endpoints. But then maybe you have some crown jewel assets somewhere where you want more specific logging off of those. So if you're not logging everything on all of your Windows endpoints, make sure you're logging more on the critical assets so that you're able to supplement what you maybe don't have or be able to get greater visibility into this system. So all of this is in place. You're going to want to hunt. And just make sure that this hunt is systematic, that this hunt is focused on your hypothesis, and it's also going to have to be time-bound. You're going to have to set some goals for how much time to use on this, because otherwise you can use all your time.
Yeah.
Is that a good process? Should it be making that API call? Is this right? Is this right? Is this right? So you're going to have to limit the amount of time that you have on your hunt. Now we've visualized where we've had our goals, we've got our data, we performed our hunt, and now we've got some results. So how do we act on these results? Why don't you?
Yeah, and when you're running these hunts, it is very common to come across unexpected results. So for example, I may run the click fix attack, and then I see a process that is executing several minutes after a clipboard. However, that could just be a malware that was executed a few seconds after a clipboard event, and that would be, for example, an unexpected result that I would still need to act upon, but it's not something that the hunt was purposed to find.
Yeah. So that would be our unexpected result, right, that we're having. And then we have some other outputs here, right? So it's going to give us security incidents, typically from the unexpected, but also from the expected if we find, for example, click fix going on. It should generate some new detections. It should generate possibly also some reports, right? So if we run a hunt and we don't find anything, that's also good information to have. That's also something that we want to communicate. And finally, metrics. You're using resources on this, and you're buying tools, and you're leveling up the skills of your employees. So you're going to need to have some metrics to show what's the value output of this, right? So we've had X number of new detections determined based on this, or we found Y number of security incidents based on this hunting that we have on the system.
Yes.
So you want to make sure that you also perform metrics.
This also helps that a lot of times it is not going to be uncommon for a hunt to not find that many true positives.
Yeah.
But those metrics showing that you've now have a more secure posture, you're now looking at different behaviors and scenarios, that can be a metric that you can use to show that these hunts have brought value to your organization.
So when your CISO calls you up at 5 in the morning and asks you, oh, I've just heard about this, how are we covered here? Do we have, we've ran that hunt and we know that we're good in that situation.
Yeah.
Yeah. So just remember, a lot of this sounds advanced that we're talking about maybe. Hunting is still, it's for everyone. You don't need to be a mature security organization, but you want to be hunting to the level of the visibility and the skills that you have, right? So we're going to be using hunting. You're going to get a higher security posture. You're going to have an opportunity for staff training and improvement. So using hunting means that it can actually help focus where your training is going to be and where your improvements are going to be. It's going to give you this highlight on the gaps in your visibility. So we want to do that hunt. We don't have visibility. Okay, let's use that to bring some visibility into our systems. And it's going to help you answer these questions and alleviate concerns. So all those questions you have, I don't know, are we using TLS 1.3 everywhere? Well, we can maybe do a hunt for it and see what areas are not using TLS 1.3 or what areas are not using the mutual authentication that we want to, or not going out through the DNS or something like that. These can all be examples of hunts.
Yeah, certainly.
Yeah. With that, we'd like to say thank you for spending this time with us. And if you have any questions, please feel free to contact us at the emails here. Thanks.
Yeah, thank you.